All right, welcome everyone to the AWS Loft, and hello to the folks on Twitch. I'm Tong, I'm an AWS Solutions Architect. So a little bit about myself. I've been with AWS for almost 2.5 years now, working with enterprise customers. Had the fortune with helping them build data lakes, and I'm excited today to share my experiences and inform you about the services that can help you on your data lake journey. So before we get started, can I have a quick show of hands? Who here is already running a data lake in AWS? OK, that's great. So everyone's new to. What about AWS Glue? Has anyone used AWS Glue before? A few folks. OK, so this is perfect, because I'm not going to assume prior experience with data lakes or AWS Glue. But if there are experts in a room, I'm here all day. I'll make myself available. After this session, we also have a hands-on workshop where you're going to get a chance to dive deep into Glue and dig deeper into the concepts that we're going to discuss in this session. We're going to keep the agenda light. So I want to start off by sharing with you some customer examples of how they built data lakes on AWS. And then we're going to go through a data lake building exercise and learn about how AWS Glue can help build your data lake. And wrap things up by giving a preview of what's next in terms of data lakes on AWS, by sharing with you information about lake formation, a service that we intend to release later this year. All right? So first off, let's level set. What is a data lake and why do we build a data lake? Simplistically, a data lake is a central repository meant to serve data of all forms, right? Whether it's structured, transactional records from a relational database, or unstructured, like audio recordings, videos, or images. And the data lake architecture should be scalable, right, to exabytes. It should be able to handle batch and streaming workloads alike, and it should be flexible to support data and analytics tools for today as well as tomorrow. It should be future-proof. And the ultimate goal, right, is to democratize your data sets so your organization can derive value from the data. And it could be to support use cases such as data warehousing and business intelligence, to solving machine learning problems in the realm of computer vision or natural language processing. Okay? So let's give some more concrete examples of exactly what a data lake is by talking about some customer examples. So the first one I want to share is the FINRA use case. Okay, so for folks that don't, I'm kind of curious, who here is aware of familiar FINRA? Okay, so some folks. So FINRA is the Financial Services Regulatory Authority in the US. In essence, they are responsible for ensuring that Wall Street operates with integrity. And in re:Invent 2017, they shared with us what it took to run their most mission-critical workload, this market surveillance platform on AWS. And their CIO shared with us some interesting data points in terms of the scale that they had to operate in. So for example, at peak, they had to support 75 billion events per day. And back in 2017, they already had over 20 petabytes of data. So some of the things that they needed to do was analyze data down to the day level, all the way up to the month. And we are at the month level, they're operating on trillions of records. And ultimately, what they need to do is they can reconstruct a market event to determine if there's any suspicious activity. Okay. I took the slide right from their re:Invent 2017 presentation. And this is where they talked about their journey of migrating their workloads from on-prem over to AWS and how they made architectural decisions, eventually landing on this data lake architecture that you see here. So some of the core decisions that they make is they decide to use S3 as the storage layer for their data lake, right? And they made the decision for all the things that people usually use S3 for, right? It's for the high availability, it's the high durability. It's because they need to operate at scale efficiently. They didn't need to manage the infrastructure, so they can scale this data lake. Another core component that you can see here on the right-hand side of that diagram is a catalog component. So when you're like FINRA and you have a lot of data sets and a lot of data, you need a mechanism to catalog your data so that your data sets are discoverable, right? And you need to have ways to govern those data sets and determine who has access to that data. Back when FINRA went on their data lake journey, we didn't have any data cataloging services. So they built their own, which they call Herd. And since then, they have open source. You can find it on the web. And once they created this foundation, the storage and the catalog, they now had an architecture where they had storage decoupled from compute, and they had the flexibility to then bring the right tool for the job. And a big component of that is leveraging something called Amazon EMR, which is AWS's Hadoop as a service. So what they would do is, let's say it's a data processing use case, they would spin up an EMR cluster with Spark and do data processing. If they need something more transactional, they can spin up a cluster with HBase and perhaps Presto if they needed some distributed queries across different data stores. In some cases, maybe they needed serverless compute, so they can use Lambda. So in essence, you can see it's a simplistic architecture, but was highly effective, flexible in the sense that they had storage and compute decoupled, and highly economical. So that's the perspective of a data lake from a large organization like FINRA. Let's take a look at the data lake from the lens of a startup. Has anyone here used Robinhood before? A few folks. Okay, so Robinhood is a commission-free trading platform. Okay? And in reInvent 2018, they shared with us the challenges that they faced that led them to build a data lake on AWS. So some of the key challenges they faced included age-old challenges, right? If you guys are experienced in the data lake realm or data engineering realm, you know that there's always been the data silo issue, right, which they call data ponds. So they had data sets spread across RDS, Redshift, third-party data stores, Kafka, Elasticsearch, and S3. And what they needed to do is provide a unified interface to their end users. The second challenge was really about economics, right? You have a rapidly growing organization, a rapidly growing user base. They're they're a trading platform. You can imagine how quickly their data was growing. And unfortunately, what coincided with that growth was a widening chasm, right, between the value that their data was delivering to the business and the cost of enabling that analytics. And the root cause of that issue was partly due to architecture and technology. So they had their compute and storage was tightly coupled. So as a consequence, as they scaled their platform, it was expensive. They weren't running analytics every day, so they had a lot of idle compute. So what they wanted was an architecture that better decoupled compute and storage and ultimately achieve better cost efficiency. And the third challenge was around data governance. So they had a growing user base, and they had users that wanted to access the data in different ways, right? And it became an increasing challenge to control who can access what data sets and how. And at the same time, with more data and more users, there was challenges around maintaining data quality. So eventually, they arrived at this data lake architecture that you see here. Again, I took the slide deck right from their 2018 presentation. And you'll notice that there's a lot of similarities between their architecture and FINRA's. And that's not a coincidence. If you do some more research and take a look at data lake architectures on AWS, take a look at what Netflix has done, you'll see a lot of commonalities, right? This is a common pattern. Typically, you'll have like an ingestion layer to handle streaming and batch. The data eventually lands in the storage layer, which is S3. And then you have the flexibility to bring the right tool for the job. So for instance, for data processing, they used EMR like FINRA. For data warehousing, they use Redshift. Some of the notable differences that you see here is they also use a couple of services, Athena and Glue. Okay, these were services that weren't available to FINRA when they started on their journey, but these two services played a critical role in Robinhood Data Lake to help them solve some of their challenges, like better decoupling storage from compute and achieving better cost efficiency. So when you take a look at Athena, Athena helped offload some of the Redshift queries. So they had Redshift serving their hot data. And Redshift was great in terms of providing the lowest latency possible on complex analytical queries. Other queries, like the warmer data, they were able to offload to Athena. And Athena allowed them to run SQL queries directly against S3 without managing a database cluster. And it provided them a cost efficiency because you only pay for the queries that you actually run. Similarly, on the data processing side, they use Glue. And Glue is also serverless. So they use Glue to run their batch ETL processes. And because it's serverless, they, again, only paid for the resources that they used during the ETL batch processing. So it's through these services that they were able to gain high cost efficiency and better decouple storage and compute. You may look at this architecture and say, hey, what about the data catalog? That was a big component of FINRA. Well, the data catalog is provided by Glue. So Glue provides ETL as well as the data catalog, in this case for Robinhood. You'll also notice that there's a lot of other complementary technologies out there. Like, for example, they decided to use Apache Airflow to orchestrate the workflow between EMR and Glue. They have their own validation layer, running their own custom business logic on AWS Compute. And for the front end, they have Jupyter serving their data scientists and Looker for business intelligence. And the takeaway, again, is you have a flexible architecture here. You have the choice to use the right AWS services that you feel is right for the job, but you also have the flexibility to use open source technologies as well as partner technologies as you see fit. Okay? Yes, there was a question? Yeah, good question. So your question is, are there any other schedulers available in addition to Apache Airflow? Right. So we'll get into this a little deeper, but there's many options. Some people choose to use like AWS sub-functions, if you're aware of that. So that's another option if you want to go down the AWS route. We're going to talk about Glue a little more later, and Glue actually has its own job workflow capabilities as well. In this case, Apache Airflow helped because they want to run workflows across EMR and Glue. So they landed on Airflow, which is a common open source choice, but there's certainly other options like step functions. Mm-hmm.
If they want to use some of them in conjunction with Redshift, then they go with Redshift Spectrum. Is that correct? Now you have an option between.
That's correct.
Standalone, then you go with Athena. If you want to use Redshift, then use Redshift.
Okay. So the question was, they could have used Redshift Spectrum as an observation, and that's absolutely correct, right? I don't know the details on why they didn't use Redshift Spectrum. They may be using Redshift Spectrum. I'm not aware of it, but that's absolutely an option and a useful complementary service for their architecture. Okay. So we saw in Robinhood's data lake architecture that Glue was a major proponent to provide the data catalog as well as ETL capabilities. So I want to dive deeper now to help you understand how Glue can help you build your data lake. So again, Glue is a serverless data catalog and ETL service. So from a data cataloging side, at high level, what it does is you can run these crawlers, it'll scan your data lake, and it'll discover data sets for you. And does this by inferring the schema, and then it can then register these data sets into a data catalog and make those assets searchable by users and systems. On the ETL side, it provides an environment where you can develop your ETL scripts and as well then deploy those scripts into and run job workflows and execute ETL in a repeatable and reliable manner. And this is all in a serverless context. You don't need to run any infrastructure, any servers, and it's built on open standards like Apache Spark and native support for open data formats as well. And we're delighted to have rapid and broad adoption from enterprise customers to startups across industries as well as across the globe. So I think the easiest way to understand how Glue can help you build your data lake is go through a data lake building exercise. So let's do that. So these are the most basic steps in terms of building a data lake. Right? First, we need to set up some storage. Right? Then we need to hydrate the data lake. And then we want to then implement a repeatable process to cleanse, prep, and catalog our data. And then next, we need to secure our data lake. And finally, we can then make the data available for our end users for things like analytics. So we're going to go through this process together. Okay, so the first step we want to do is we want to set up storage for the data lake. And we're going to use S3. So has everyone here used S3 before? Okay, most people, okay. So you know how easy it is going to be to set up storage. We're just going to create some S3 buckets. But let's pause for a moment and validate that S3 is the right technology. So if we're going to build a data lake, it's going to serve analytics. I think it's reasonable to assume that we will have some high-value data that we need to ensure high availability and high durability on, right? So we know that S3 replicates the data for us across multiple availability zones to provide that availability and durability. We're also likely going to have some sensitive and confidential data, right? So we're going to have to lock down the system. You got S3, mature cloud storage, so we're going to have some mature, we have the comfort of knowing that we have mature security controls in place, as well as industry best practices and security accreditations available to us. The data lake also needs to serve data of all types, right? We talked about structured and unstructured, and that's what S3 is designed for as well. And finally, scale. And I'm not talking about just having a storage layer that can scale to exabytes, but at the same time, it needs to be manageable, right? As it scales to petabytes and exabytes, it needs to be manageable, and that's, as we know, where S3 shines, because we don't need to manage those servers, right? As well as our data lake scales, we need to ensure it's economical. So S3 also has mechanisms like intelligent storing, as well as lifecycle management, so that it can automatically move our data to colder storage for cost optimization. So it's got all these capabilities to ensure that we can scale, that it's economical, that it's secure. So once we've set up our S3 buckets, we need to hydrate our data lake. So chances are we're going to have a lot of data sources that are on-premise that we're going to need to bring into our data lake. So one option we have is, let's say we got tens of hundreds of terabytes of data. We can use something like Snowball. So Snowball is a portable storage device. We can pack up data into Snowballs. We'll ship them over to AWS, and we can hydrate our data lake that way. If you're one of those organizations that have hundreds of petabytes, I'm kind of curious, does anyone have more than 20 petabytes of data here? Okay. Relatively rare, but if anyone on Twitch has a lot of data, there's some organizations that do have hundreds of petabytes or exabytes of data. Some of you may recall back in reInvent 2017 when we drove that semi-truck on stage. Was anyone there? Curiosity? Okay. So you got to check it out. Keynote reInvent 2017. We drove a big semi-truck on stage. That's AWS Snowball, right? So if you want exascale transfer, we can have a fleet of Snowball trucks, right? Transfer your data over to AWS. In addition to migration, in some cases you want to operate in a hybrid mode. So you can use Direct Connect, which gives you a dedicated private connection between on-premise and the cloud, and you can send data over a 10 gigabit pipe, which you can expand on a need-by basis. Alternatively, you may want to build a hybrid storage architecture, some data in on-premise storage, some data in AWS like S3, and something like AWS Storage Gateway can help you build that type of architecture. So those are other ways you can hydrate your data lake. In addition to migration and batch, right, you're probably going to have some streaming workloads. Does anyone here have streaming workloads on things like Kafka and maybe IoT, a few folks, right? So if you have streaming data sources, you have many options, including using Managed Kafka. If it's IoT, there's the IoT platform, and then there's Kinesis data streams and Kinesis video streams and Kinesis Firehose as well for stream ingestion. So once we've hydrated our data lake, we want to cleanse and prep our catalog in a repeatable manner. And this is a critical part in our data lake exercise. So one of the things that analysts like Gartner is observing is a lot of organizations are suffering from a problem called dark data. Essentially, they're collecting a lot of data, but they're becoming less effective in deriving value from that data. So one of the things that you don't want to fall victim to is dark data as you build your data lake. So Glue is going to play a critical role in terms of ensuring your data is discoverable, right, through cataloging. And it's also going to provide cleansing and prep to ensure your data remains at high quality. So this slide deck shows you the diagram here. It gives you a sense of all the major components in Glue and how they work together. So at the very bottom, right, you see like a simplistic ETL pipeline. So you have data that's flowing into your data lake in S3 in raw form, and you can then trigger like a Glue job. That Glue job may then run some cleansing routines, some basic transformation, and it'll stage the data back into S3 in your data lake, right? At that point, you may then trigger off some additional Glue jobs to transform the data into optimized format. For instance, you may have a Glue job that will partition the data and convert the data to ORC or Parquet so that it's optimized for Athena or Redshift Spectrum. And as you create those data sets and as those data sets come into your data lake, you can run these crawlers, right? And these crawlers are going to scan your data and discover these data sets and catalog them into the Glue data catalog so that it's now discoverable by users as well as downstream systems. So as we build this data lake, you can see that the crawlers are going to play a critical role in helping us make our data discoverable. In effect, it's going to help us automatically build our data catalog and keep the data catalog in sync. So some of the things it's going to do is like we'll go in, we're going to configure the Glue crawlers. We may set up a schedule so they run on a regular basis. They'll scan our data lake, and when they discover the data set, they can infer the schema for us automatically. If it's an existing data set, it can detect the changes and track schema version changes on our behalf. It might detect partitions for us automatically. It can also classify the file format for us. You know, is it JSON? Is it Parquet? Is it ORC? And as well, automatically derive things like data statistics on our behalf. And it all operates in the spirit of serverless, so you only pay for the crawlers when they actually run. So let's give you a concrete example. So let's say when we build our data lake, we start collecting customer reviews from our website. And we go configure a crawler, and it scans our data lake, and it finds this data set. So one of the things I'll do is, as you can see on your right, you can see that there's a schema. So it can infer the schema for you automatically. And then you can see that it will then build various statistics for you on your behalf. So for example, it detects the location of the data set. The format in this case is Parquet. Data statistics are things like the number of records, the average record size, and then the option to also add custom properties. And in this case, at the very bottom, you can see that it's also detected some partitions for us. All right, so now we have our data catalog set up. We have these crawlers, they're keeping it in sync. Now, let's talk about the ETL component. So the Glue ETL component, it's built on top of Apache Spark. Who here has experience with using Apache Spark? Okay, many of you, that's great. So Glue runs on top of Apache Spark. For those who are new to Spark, it's essentially an open source distributed data processing engine. So what this allows us to do is we can run our Apache Spark scripts in Glue if we wanted to. And we can write the scripts in PySpark or Spark Scala and run them in the context of batch ETL. And we can use the core constructs, for example, RDDs, resilient, the RDDs as well as data frames, and as well as run Apache Spark SQL as needed. But you also have the option of leveraging the Glue library extensions. For example, there's dynamic frames that are available that are in Glue that are better optimized for batch ETL. And they include some helpful utilities. So for example, let's say we needed to flatten some nested JSON data so that we can load the data into a relational database. We can use a dynamic data frame and run a relationalized transform to flatten that data for us and just simplify our scripting logic. There may be some cases where you may want to leverage best of both worlds. So for instance, again, maybe I have some JSON data and I want to leverage these dynamic frames to flatten my JSON data. But I also want to do some complex transformations where I want to leverage Spark SQL. So there's utilities here where you can transform between the Apache data frames and dynamic frames in Glue so that you can leverage best of both worlds. Now, if that doesn't provide you all the capability that you need, there's also the option for you to import custom libraries. So once we've created our scripts, we can then run them in Glue. And there's going to be scenarios where you want to run incremental jobs, right? Incremental processing and load. And this is where we want to configure job bookmarks for those use cases. So job bookmarks essentially allow us to keep track of previously processed data. The second thing we want to do is avoid script proliferation. Right? Some of you may have very complex data ecosystems. I've met with customers who have hundreds of databases. It's possible that you can have a database that has over 1,000 tables. Out of curiosity, is anyone in that situation? Okay. But in that situation, all those tables could be data sources. And the last thing you want to do is write a script for every slight variant. So it's important to support reuse of our ETL scripts. So there's some things that you can do. You can build job workflows where each of the job represents a logical unit of work, and you can have like a ETL script triggered downstream in a workflow for reuse. As well, we support the ability to parameterize your scripts so that you can create more generic scripts and then launch these jobs with parameters as well to, again, facilitate reuse. So let's talk a little bit more about the job workflow. So we mentioned earlier in the Robinhood use case that they use Apache Airflow, and there was a question, right, that yes, you could do that. You can also use AWS step functions. But if you're only operating in the scope of Glue, it might be easier for you to just use the out-of-the-box job workflow capabilities in Glue. So for instance, you see in the diagram here, imagine we want to create a job workflow where we have new data that's being added into our data lake at night, and then we want to launch a data cleansing job in the morning. So we can create a schedule trigger for that job to run, cleanse the data, and create a data set for us. Once that job ends, we can have a trigger on that job. If the job succeeds, it can launch, let's say, a handful of Glue jobs. Some of the Glue jobs may partition data, convert it into Parquet, so it's optimized for Athena. You may have another Glue job which transforms the data into like RDF or Gremlin so that you can load it into a graph database like Neptune for graph traversal analysis. Right? So that's an example of some of the job workflows that you can create with the out-of-the-box capabilities in Glue. So in essence, you can create triggers based on schedules, on demand. It could be triggered by job events, whether the previous job succeeded or failed. And you can configure things like retries and timeout. OK, so now we've created this data lake, and it's like a well-tuned machine, right, where we have these crawlers that are keeping our data catalog up to date. We have these ETL processes that are now automated through job workflows. How do we know that everything is working well? And how do we know when there is a problem? Well, we can do this by going into the Glue console, where we have CloudWatch dashboards and metrics available for us. So for example, Glue provides metrics like memory usage, bytes in and out, bytes shuffled, the number of executors that are needed to execute your Glue scripts. And this allows us to do things like debug out-of-memory issues, detect data skew problems, as well as detect opportunities for optimizing your scripts and your job configurations, right? And just like basic CloudWatch, right, you can set up alarms on these metrics. So for example, we may want to have a notification when a job fails. All right. So the next step that we want to take in building our data lake is to secure our data lake. So imagine a scenario. Maybe we want to run customer analytics, a customer analytics workload on our data lake. Quite possibly, we may have PII data, right, that we want to analyze. So we want to make sure we lock down that data lake. So the first thing we want to do is lock down the data storage, which is S3. And I think many of you may have already done this before. Essentially, what we want to do is we want to create IAM policies, right, where we limit users and roles in terms of the minimal access that they should have, right? They should only have access to certain buckets and objects. And we want to complement that with bucket policies. So those are resource level permissions that we want to use to limit access within our data lake. We also want to employ the proper encryption strategy as well. So sometimes it's convenient to use S3 managed server-side encryption. But as you know, S3 has also many other encryption strategies. Sometimes you may want to use KMS with S3 because for compliance reasons, you want a separation of concerns where you want to have your security team manage your encryption keys, but your data lake and S3 administrators manage access on the data lake. So you need to think about what would be the right encryption strategy based on your needs. And lastly, we want to employ best practices around tagging. So we might want to use, for example, we want to tag our objects with our classification level. So if we have PII data, we want to maybe tag it as PII. And what that lets us do is scope down our IAM and resource policies so that we can, for example, in our rules, create like a deny on a deny rule for access to any objects that have been tagged as PII. Okay, so in addition to securing our data, we also need to secure the data catalog. And this is where Glue provides you, similar to S3, right, IAM policies to control what users and roles can modify and view the catalog, as well as resource-based policies where we can apply the same permissions on the catalog objects. So for example, here, this diagram shows the different objects in the catalog. We have databases, we have connections, and within databases, we have tables and user-defined functions. So Glue allows you to define fine-grained access controls where you can specify who has the rights to access things at the catalog level, the database level, as well as the table level. Okay. All right, so now that our data lake is secure, we are now ready to share the data with the rest of the organization, right? For example, for analytics. And Glue makes this relatively easy through its integration between the Glue data catalog and services like Athena and Redshift Spectrum. So through Athena and Redshift Spectrum, you can expose the data lake assets in the form of databases and tables. And then downstream systems like business intelligence tools now have visibility into those data sets and can use Athena and Redshift to query that data. Right? Likewise, in EMR, you can use the Glue catalog in a place of the Hive Metastore. So imagine like a machine learning use case. You can create a machine learning pipeline where you extract data from the data lake through the catalog, and then you can create a pipeline which processes data, does some feature engineering, and then maybe integrate with our machine learning platform, SageMaker, to build and train a machine learning model. Okay? Right, and that's all it takes with the help of Glue to put together a strong foundation for a data lake. So let's kind of recap what we built. So we have a bunch of different data sources. Data's coming in both batch streaming. We have migration scenarios. And we have mechanisms to ingest that data into AWS and into the data lake. We then use Glue to cleanse the data and prep the data in a reliable and repeatable way. And we have these crawlers that could run automatically as well to detect these data sets and catalog the data for us. And once the data is cataloged, then you can, through the integration with Athena, Redshift Spectrum, we make it easy for our end users to access the data lake assets through business intelligence tools as well as machine learning platforms. So the final topic I want to touch on is lake formation. So out of curiosity, has anyone heard of lake formation? Okay, just a few folks. So in reInvent 2018, we announced that we were going to release a new service called Lake Formation sometime this year. And the intention was to make it easier for customers to build and manage data lakes on AWS. Think of Lake Formation as a service that's going to complement Glue. In fact, it's going to leverage Glue heavily. And it's going to augment and build on the concepts that we described today. So some of the capabilities it's going to provide is the concept of blueprints. So essentially the idea is there's a lot of out-of-the-box ETL capabilities that we can provide for our customers, right? We don't want all of you guys reinventing the wheel. On the first release of Lake Formation, we're going to provide blueprints to simplify the import of data into your data lake. So we're going to provide the ability to extract data from relational database sources, like from RDS Aurora, for example, and load that data into your data lake in the form of one-shot or incremental. We're also going to release a capability called ML transforms in Glue, along with Lake Formation. And the first use case that ML transfer is going to support is around deduplication. So how it's going to work is you can train Glue to learn what how to detect duplicates in your data sources. So it could then do fuzzy matching on your behalf, detect duplicates for you automatically, and again, ultimately make it easier for you to maintain high data quality within your data lake. We're also going to improve data governance by providing a central administrative interface for lake formation. So if you recall, when we were going through the steps of building a data lake, we talked about, hey, we need to secure S3, right? We need to then secure the data catalog. But it's actually not that simple as your data lake gets more sophisticated, because you may use Redshift, you may use Athena, you may use EMR. As you know, they all have their own IAM controls that you need to configure. So as your data lake grows, as your users diversify and they use different tools, it's a lot of administrative overhead. And that's a problem that we want to fix. So Lake Formation's going to simplify that issue by allowing data lake administrators to control user access centrally. And those user access controls will then take into effect across the AWS services. So if a user then uses Redshift or EMR or SageMaker to access the data sets, then we're going to have lake formations user access controls take into effect. So you can secure once and then enforce access in multiple ways. And another big enhancement is around searchability and collaboration on a data catalog. So some of the things we like to do is allow users to add custom business metadata, where we talk about how crawlers can automatically add technical metadata for you, but our customers also want to add business metadata to the catalog. They want to make the catalog more searchable, right, as well as searchable through the custom metadata that they create. So we're going to provide better full-text search capabilities, faceted search, as well to make, again, your data assets more discoverable. Okay. So I want to wrap things up by just giving folks a couple of helpful tips that my customers found useful as they were going through the data lake implementation process. So first off, we talked about some encryption options, right? We were aware that S3 provides a number of encryption strategies, but be aware that the data catalog, the metadata, and some of the Glue components are not encrypted by default. So there are additional encryption options that you may want to enable. So such as the metadata in the Glue catalog, as well as the connection information that you store in the catalog, down to the CloudWatch logs that are generated by Glue. Those can be all encrypted, but you need to make sure you enable them. Secondly, take advantage of serverless, right? Not just think about optimizing on costs, but think about optimizing both time and costs. So here's a screenshot of one of the charts that are provided by Glue. What this is showing us is this is a run of a Glue job. And in this case, it took 6 minutes to run. And we've allocated 17 executors. This is the resources that was allocated to this job. And you can see that from this chart, what it shows us is that the script actually needed a lot more executors. So these executors, for those who aren't familiar with Apache Spark, essentially they're the workers, right, that allow us to run tasks in parallel. So because the allocated executors is less than the needed executors, there were pending tasks, and if we added more resources, there's a potential of this job completing faster. If we take the extreme case, where we allocated enough resources for 107 executors, right? If you look at the chart here, at peak, we needed 107 executors. If we did that, you can see that the Glue job would run in half the time in 3 minutes. Okay. So that saves us on time, but it actually ended up costing more because we allocated around 6 times more resources, even though we cut down time. But there's probably a sweet spot somewhere, right? Maybe if we allocated enough resources for 20 or 30 executors, maybe there's a sweet spot somewhere where we can optimize both time and cost. So make sure you leverage these CloudWatch metrics to help you optimize your Glue jobs, and this is where you can optimize on both time and cost. The final tip, and this is a new capability that was just released a couple of weeks ago, is Glue now supports resource tagging. So you can tag your dev endpoints, you can tag your Glue jobs, as well as your crawlers. Like in this example here, I have a tag that indicates these are resources owned by the development team. And this is going to pay dividends in terms of cost governance. So I can create cost allocation tags, and I can now see which teams owns and spends what resources, like what's their Glue spend, as well as, again, provide better security. So with these tags, I can create conditions in my IAM policies and resource policies to limit, for example, the dev team should only be able to run jobs on resources that are tagged by the dev team, right? And ultimately, if any of these resources or any of the entities are compromised, again, we can limit blast radius. So that's the end of the presentation. If we have some time for some questions. What's next is a Glue workshop. And if you guys don't have any questions, feel free to take a break. And thanks everyone on Twitch for attending this presentation.